Hello everyone, and welcome to our second episode of Taming the Dragon webinar series. Today, I have with me and with all of you, Luca Cominardi, which is a Zenoh product conductor. And in this second episode, Luca will be taking us a little bit deeper into the world of Zenoh and getting you really started into writing actual Zenoh code. So, as usual, the handout for these and all previous episodes are available on the handout section. So take a look just above the chat and it will be there. Ask questions as we go through the webinar, but we will answer all of those at the end. And once again, if there are too many questions and we don't manage to answer, be assured you will get an answer by mail. Okay, so in any case, don't hesitate to ask questions. We will make sure that we can answer all of them and eventually follow up by mail. So without further ado, Luca, the floor is yours. Thank you very much.
Thank you very much, Angelo, for the introduction. So let's get started with some Zenoh code and Zenoh concept. So just a recap from the last episode on what is Zenoh for who basically missed it last time, didn't have the opportunity to recap it. Just let's go through quickly on what it is Zenoh and what is expecting ahead of us. So last time we got Zenoh Genesis from Angelo. This time getting started, and you can see on screen and also on the invitation reminder the next episode. So glad to have you here today, and waiting also for you for the next episodes. So Zenoh is a technology that really unifies data in motion, data rest, and computation from embedded microcontrollers up to data center. So today we are gonna see what it means that unified data in motion, data rest, like for specifically for PubSub and distributed queries, and how to use the API, right? So we're gonna dive with some real example code for what location transparent API means and what we means that Zenoh can facilitate jet distributed storage, and also with the integration with third-party technologies. So this is something that really want to show you, to make aware that what's the really inner concept of Zenoh and what you can do with it. Zenoh is a technology stack that, just for a reminder, that can run everywhere, right? So from on top of data link up to the transport layer. So we can have a Zenoh stack working on top of TCP, UDP, QUIC, TLS, but as well on top of serial connections and Bluetooth. And this allows us to target also embedded devices, which will not be covered today, but will be covered in our next episode. Zenoh also provides any means for you to build your topology that is really suited for your use case. So you might have your Zenoh application that can work on a peer-to-peer fashions, or in a broker mode like an MQTT, or really with a more complex scenario that is routed, where you can have complex network where data is routed by Zenoh. You can see an example here in the picture, and we can see some code examples later on in this episode. And it's also extensible, so it means that Zenoh can interact with other technologies that could be either storage technology like InfluxDB, RocksDB, MariaDB, etc., but also with other messaging protocol like MQTT and DDS, or also for some web-based technology like REST API or HTML5 SSE. So let's get started with some real code. And to get started with some real code, well, first of all, you need to choose to pick your API, right? So Zenoh is natively written in Rust. So that provides, of course, a natively API in Rust with also asynchronous support. And on top of this Rust implementation, we also provide some bindings like Python or C, or that some coming bindings like C++ or Java. For what concerns C, as just said, we've got some native library. We've got a bindings built out on Rust, but also we have a native library for embedded target that is Zenoh Pico. But this is for another episode. How to get then DPI? So for what concerns Rust, if you're familiar with Rust, it's enough to include in your cargo terminal the dependencies to the Zenoh crate. The latest version is 060 beta 1 that is published on crates.io. Or if you want to really go to a bleeding edge and go test nightly, you can directly point to the Git repository as is shown here. With Python, we publish all the packages on pip, so it's enough to get your virtual environment or your Python environment in either a native, global, or local. You just use pip to install it. Pip install Eclipse Zenoh for the latest release, that is 060 beta 1. Or again, if you want to go to nightly, pip install Eclipse Zenoh nightly. That's all that you need to get started with Zenoh. So let's start writing some code now. And what kind of code? Let's delve into the examples of writing some PubSub. And why would you use PubSubs? Many of you, I'm pretty sure that already know why would you use PubSub, but just to put everyone on the same page. So in the case that you need to distribute values that are published at a given point of time by someone, for example, in these slides by a thermometer, like a little sensor that needs to publish the temperature of a room, you can use PubSub, and this data will be delivered to any subscriber that is interested in that data. So we are introducing a bit of concept of what location transparent means for Zenoh. So you can see here in PubSubs, we are talking about data that is published and subscribers that are interested in that data, regardless to who really published that data or where that data is published. So you can see here in the figure that we've got a thermometer that really publish on the key expression, as we call it in Zenoh, room/kitchen/temperature, the actual value, the actual measurement of the temperature, that is 21.5. This data, once published by the thermometer, will be taken care by Zenoh to be distributed to identify all the matching subscribers and to get the data to them. So what does it mean, matching subscriber? It means that we use also writing here the term key expression. So we are able in Zenoh to express a set of keys with a given syntax. That means you can have a key that is exactly matching the publication, so room kitchen temperature. So we might have a subscriber to room kitchen temperature. We might also have the use of single wildcards, that is room kitchen/star. That means that we are going to receive any data published by any sensor, for example, in the kitchen. We might also have a double stars. That means that we might have anything in the middle here as deep as we want, and we will match it. So room kitchen single star, that means that we are going to match only one chunk of the key expression, while double stars, that we may match 0 or multiple chunks of it. And of course, in this example, you might have home alarm status that basically is not matching, so any subscriber on that will not receive data being published for it. So how the code will look like to have something like that. Let's move to the first example written in Python. So I install it with Eclipse, with the pip install Eclipse Zenoh, and the only thing that I need to do to create a publication, right? So to write some data on top of Zenoh is the following in Python. It's literally 4 lines of code. The first line, of course, we need to import the package, so import Zenoh. This line tells to open a Zenoh session with a default config. So we just do Zenoh open Zenoh.config with a default config. We can go deep into details what opening a session means. I'll just wait for a few minutes for that, and what kind of things we can configure with this. But assume that we open a Zenoh session now. What you can do, you take this session, we just do a put operation on what? On our key expression, that room kitchen temperature, and we put the value, 21.5. And we close the session. That's it. Nothing more to get started with Zenoh to publish some data. This is on the writing side. but we say that we write data because there is someone interested in it, right? So if there is nobody interested, what's the meaning of writing data? So how can we express interest of receiving data? So how can we write our subscriber? So I'm just gonna put it side by side so we can see better the complexity of getting started. So again, for writing a subscriber, we need to import the Zenoh. I'm just jumping here a few lines to follow me. We open a Zenoh session and we need to declare that we are a subscriber that we are interested in any temperature of any room, right? So room / start, that means this is a placeholder, wildcards / temperature. So that means that you can receive the temperature of my kitchen, my bathroom, living room, bedroom, etc. And in order to receive data, I need to provide a callback. Okay, this is one option to provide data is via callback. Later on, you can see that we may also have different ways to get data via streams of data. But let's focus for the time being on the callback. And what does the callback receive? This is a Zenoh sample. A sample contains a value with a given payload and a given encoding. So in this example, everything that I'm doing is just taking the payload, converting to a float, that is the type that is provided by the write, by the put, and just printing up on screen. So if we show some nice terminal for that, I'm just gonna run one side a subscriber, another terminal, and just writing the put. You can see that we open a session and the subscriber received data that was published on room kitchen temperature. The value was 25.1 and the encoding was application float. So let's get a bit more in details about this kind of what does it mean, application float, this kind of encoding. So let me just quickly jump back to the slides. So just leaving a bit of time in order to refresh the streams, because it takes a bit of time when I do it. So encoding. So what does it mean, encoding in Zenoh? What's the purpose of it? How can we make use of it? Right. So Zenoh, when we publish data and when we receive data, there is some metadata information that is attached to it. That is the encoding that hints us on the type of encoding of the actual payload. So the payload in Zenoh is a set of bytes, right? So we don't restrict Zenoh to a specific encoding, but just you can put whatever you want in it. And we have this metadata information attached to it that tells you how you should interpret those data. So to be compatible for what is around in the industries with a MIME type, so we base the definition of that and we just adopt it, but you can also define your own encoding. Just let me get some examples of a put with encoding that I've got here. So what does it mean to do put with encoding? It means that Zenoh, by default, especially with a Python API, also with a Rust API, it automatically detects the encoding of the data that you are passing to it. For example, if I just do a put with an integer, that will mean that Zenoh will automatically set the encoding to integer. If I put a float, like in the example of the temperature, will automatically set to float. If I put a string, you might have a string encoding, or for example in Python, if I pass an arbitrary structure like a dictionary or a list containing dictionary, etc., this could be automatically converted to JSON. But we can also put some raw encoding, right? So you can see here just the byte representation in Python. If I just put a byte representation, this will be just interpreted like application, like a stream of octets, so like byte stream. But I can also set my actual encoding. For example, I'm defining my own encoding, I could set it with a custom encoding and just define whatever I need in my application to signal the actual encoding of my data. So if I just open the wrong file, just putting side by side again, in the case of subencoding, you can see that it's the subscriber, like the one before, but in the callback, basically, we are going to check the type of encoding of data to apply the right conversion of it. Like if it's up integer, we just convert an int, in float, in a text, if, for example, text plain encoded by default in UTF-8, JSON, etc., etc. Right? So if you just rerun some example of the subscriber, but with the encoding support, sorry, wrong command. There we go. And just put things with encoding. You can see that you can publish data with different encoding. According to the encoding that you get, you can decide how to decode it. Now, there is an additional way to publish data in addition to encoding, right? So encoding is a way to attach metadata to it, but you can see right now the only examples that we did, we open a session, we put some data according to a key expression, and then the value. Right here is just one write, and we open a session, we close the session. Here also with the put on encoding, we write always on different key expression every time that we write. But what if we would like to always write on the same key expression? For example, our temperature sensor that periodically, like every 5 minutes, write on that. In Zenoh, we can also have a publisher that is not mandatory, but you might have it, that declaring a publisher would allow to Zenoh to perform additional optimization under the hood. Right? Now is not the right time to talk about those kind of optimizations, but if you are always published on the same key expression, it's a good practice to declare a publisher for it. Right? And when you declare a publisher, it's enough to declare your key expression on which you want to publish, and then every time that you want to write, you take your publisher and you simply put the value. So no need to carry around your key expression in multiple places. Just declare a publisher once, you take your publisher, and you put the data that you want every time. So in this case, we are publishing every second. You don't need to change the subscriber for that. The subscriber is still the same. Just take your data, the publisher, you run it, you open a session, you see that we're going to have a publication every second with the actual encoding that was afloat. So far, it's in a bit of magic, right? So you say, okay, we open a session, and we've got a publisher and a subscriber that magically starts to communicate. But how they start to communicate, what does it mean, and why does it work, right? So you saw in the code, just open a session. We didn't provide any information about who is on the other side and where to connect and how to start communicating. So this is what we just experienced and saw is the examples of peer-to-peer communication in Zenoh, right? So this is just a publisher, subscriber. There is no broker in the middle, no router in the middle, direct communication between them. And peer-to-peer is really one of the communication models supported by Zenoh, where Zenoh peers or Zenoh nodes can talk directly with each other without intervention of any Zenoh infrastructure. Just ramp it up, direct communication, and your own business. But how can you really get this direct communication between peers? Again, in the code you saw it, we didn't define anything for that. That's because of multicast scouting that is available by default in Zenoh. So what does it do? Zenoh, when boots up, when you do the Zenoh open, the default configuration performs some sort of scouting. That means that scouting is a subprotocol of Zenoh that allows to discover who is around, right? So it's based on a UDP multicast. So in order to have it working, you need to be able to work on a network that supports a multicast, otherwise it will not work. And the only purpose of this is to discover who is around. I'm sending out a scout message, say, hey, is anybody around there? And anybody around there, reply with a hello message and says, yes, I'm around, it's me, it's my ID is XXX YYY, and I'm a router, I'm a peer or my client. So I can get a view on who is around, and then to establish a direct connection, for example, if we discover that there are two peers. So when we just started in the example that we got a peer and a publisher and a subscriber that then open with the default config, that's what's happening under the hood, right? So good. So we just seen PubSub in a peer-to-peer. Now let's introduce the next mechanism that we have got in Zenoh. That is query reply. So PubSub, done, easy. What is query reply that? And what is used for? So usually you want to use query reply to request the on-demand some values, right, in your network, by the means of a distributed query that will hit any matching given key expression. So the mechanisms of matching key expressions is the same mechanism that we got in PubSub. That is in overall Zenoh, whenever you talk about key expression, you always talk about this way of structuring different chunks like room / kitchen / temperature and the use of wildcards. That is either a single star or double star. So let's assume that I've got an application on my mobile phone and I want to know the actual reading of the temperature in all the rooms of my house. So what I could do is to just do a get on a room / star, where star really will match any room / temp. This query will be then distributed by Zenoh to any matching querybles. So a queryable is someone that will receive query and will be able to. So we've got publisher subscriber, right? In the PubSub, we've got a querier and a queryable in the query reply. When that query hits the queryable, then on-demand reply can be generated to give, for example, the actual temperature reading. So let's see how to do that, how to write some code that can help in doing this query reply. But this time, instead of doing it in Python, we're going to show you then another API, the Rust API, in order to do the get. So I'm just switching from one Visual Studio Code to another, and we're in business. You'll also be able to appreciate that the look and feel, the logical steps that you need to do in every API is, in every API means that with Rust, with Python, with C, etc., it's always the same. So when you work with Zenoh, regardless of the API, you always have the same logical steps to follow. And we really work hard to do that. That's a way that if you want to work with Zenoh in a given language, and then you have another part of the system that requires for any reasons to use a different type of bindings or language, well, you don't need to change your mind. Just follow the same steps, same workflow, flow of thoughts, and you're in business. So similarly to what was done in Python, so we need to import our Zenoh package, and we import the asynchronous prelude for that. And we provide some asynchronous example. You can see that the first things that we do, import the package. The second thing that we do is to open a Zenoh session, again, with Zenoh open, with the default config. And then what we can do is then, taking our session, we can get, for example, on our /temperature. And we resolve in this asynchronous way the future by this res.await, and then we just get the result of it. And then once we issue our query, we can iterate with a stream type of API on the stream of replies that we can get, right? Every time that we receive a reply, we've got a sample that can say that whether the reply was an okay or an error. And then we can, in a more automatic way, because of Rust, convert our data that was providing an application float directly to a float 64 bits, right? And then again, we are gonna print on screen the type of data we just received. So this is on the get side, right? But what would the queryable side, so the ones that really answer the queries, will look like? Again, I'm gonna put it side by side to see the difference. So what we're gonna do here, again, for the queryable, we import the package, we create a key expression on which we wanna answer, so to reply. So we can do it this with a key expression, try from, and our room bedroom temperature. For example, now we are gonna respond for our bedroom temperature. And again, we open our Zenoh session. And what we do is to declare a queryable. So either you declare a subscriber, right? Here we just declare a queryable. So every time that you want to declare something in Zenoh, you go to the declare keyword and then subscriber, queryable, publisher, or anything that might be needed, right? Declare queryable on what? So say, hey, this is my expression. That's what I want to answer to. And then, again, we've got a stream API, a synchronous stream API, where we've got our queryable that will receive a stream of queries. So what I'm going to do here, I can retrieve on which key expressions the query was issued, and then I can prepare my reply. So I just create some random, well, not random, it's actual fixed static temperature reading, so 19.5, and I create a value for that. And then you can see that I'm printing out the reply. You can see that while these conversions, again, Zenoh can automatically set the encoding for you depending on the type that you are encoding. And then I can, based on my query, I can do query.reply, and I can say, okay, this is okay reply, and I provide back new samples with the key expressions that are responding on, that's room bedroom temperature, and the actual reading that is 19.5, right? So let's see it in action. Again, switching screen, switching terminal. Now we're looking at the Rust part of it. So I just run the queryable here. And what I can do, I can also run the get here. You see that I queried on /temperature, and I replied for anything that relates to the bedroom, that is room/bedroom/temperature with the actual reading. And this reply is then received by the getter. They receive back, hey, this is a reply for room bedroom temperature 19.5 application flow. Similarly, I might have multiple queryable that will answer at the same time. So I just starting two instances of the same queryable. Again, see that we got a query that it you can see here, both reply for with some data regarding room bedroom temperature, but then you can see here that I received only one reply, that's 19.5. That is because Zenoh automatically for queries does consolidation. So if you've got multiple replies for the same key expressions, by default, you receive the latest values for Zenoh in such a way you don't need to deal yourself in applications for multiple, you need to filter out the different replies. And by default, you have multiple, you can hit on multiple hits, and if you've got the same key expression, Zenoh will consolidate for you. So here is just a screenshot of that. So let's go one step further now. Distributed storage. You have seen PubSub so far. You've seen query reply. What if we combine them? What we can get out of it? Well, if you think for a moment, what is a storage? A storage is someone that wants to receive data. I mean, its interest is to receive data as soon as the data is freshly produced, and to be able to provide back the data when someone is interested in it. So if you take this example, right, that we've got again our sensor temperature that produce data on room kitchen temperature that can produce it periodically, and you've got a subscriber that a room/star temperature, that means that I'm interested in storing all temperature measurements in my house, and at the same time I declare myself also a queryable for room/star/temperature. That means that every time that a sensor publishes some temperature data, that will be stored, and every time that I want to have some reading of it, just need to issue a query, and that query will hit, again, because it's a queryable, my storage, and will reply back. So if you think about it, really, those are the basic pieces, the basic gears that in Zenoh will then allow us to get this distributed storage, right? So let's see a quick example, really, for the tutorial purposes, how to implement a storage with Zenoh by combining those two concepts of PubSubs and query reply. We are going to do this again in Rust, and to see what will look like. So here we go. And we import the Zenoh prelude for asynchronous plus a Nash map that we are going to use for storing our samples, and some other feature X prelude for asynchronous STD. That's a library for Rust. And since the hash map is going to be shared across different asynchronous tasks, we need to protect it with a read-write lock, and we provide an atomic reference counter for that. But let's go step by step there. Again, we define our key expression on which we want to provide our storage, that is room/star/temperature. Then we actually instantiate our storage, that is atomically reference counted read-write lock on the hash map. That means why read-write lock? Because when I subscribe to it, it means that I need to write on the storage. When I receive a query, I need to read on the storage. So that means that I might have multiple concurrent queries at the same time. I'm still able to read. Subscriber. It's pretty similar to what was on the done for the querybles. So I've got my session, storage, and the key expression. Just in this case, these are very things for Rust. I need to clone it in such a way to give a known version of it to the asynchronous task that will handle my the subscriber, right? That will handle any incoming new samples. So once I created that, I spawn a new task, right? That you can, if you're not familiar with asynchronous programming, think about that that you're spawning a new thread, but it's way more lightweight. But the kind of synchronicity and concurrency problems will always be the same category, right? So we spawn a new task, we declare a subscriber on our key expression, so room/star/temp, and we are using the stream API. So what I'm gonna get back is a stream of samples that I receive via my subscriber. I'm gonna wait for it, right, or receive on a synchronous way. And again, this is just for for the sake of this tutorial, to show that the conversions are to print at a screen, but it's not necessary just to store your data. What you're going to do every time that you receive samples, well, it's an hash map. I just get the write lock on it. And what I'm going to do, I'm going to use the key expression as index of my hash map, and then going to put in my sample. That's it. Every time that someone's wherever in the world that is connected to my data infrastructure start publishing some data, since I declare a subscriber, receive the data, and boom, I'm going to store it to my hash map. So this for tutorial really is, can already imagine, is I'm storing everything in memory, right? But nobody prevents you that instead of storing in memory in hash map, you can go and use any type of backends that you like to use. We are good for the subscriber side, so to store data, but how to retrieve data? Queryable. Again, I'm going to have a dedicated task for that. I'm going to clone the key expression, the storage, the reference to the storage, the reference to the session. And what I'm going to do is to declare a queryable. And similar that I did for the that queryable before, I'm going to use the stream API, iterate on an incoming query. And every time that I receive a query, I'm going to take a read lock on my storage. And what I'm going to do, this is a simplistic way to do it, but I think it really gives you the right hints for this kind of tutorial to get started. I can iterate on all my keys or my hash map, and I can verify which key expression intersects with the key expression of my query, right? So it's saying that we've got wildcards, we've got, so we need to verify whether those wildcards intersect everything that has been stored in our storage. Okay, perhaps it's not the most optimal implementation for it, but I think it makes the point to for the concept that the key expression can intersect and match each other based on the semantic that we have on the wildcards. And once we identified, right, we filter out all the key expressions that really match in our storage, what we can do, you can iterate on all those samples and to provide replies for each samples. Pay attention to this. I got one queries, but I might call the reply multiple times. That means to a single query may produce a stream of replies. Let's assume, for example, a use case that one of our users on the Discord channel pointed out last week. They say, hey, I got a query, but I want to retrieve, for example, a big file. I don't want to store everything in memory. Can you chunk it up? Well, you could. Also, you could have a query that provides back a stream of replies by taking a big payload and chunk it up in a different chunks, and then you're assembling on the other side. Right. So let's see it in action now. We've got subscriber, queryable. You've got a storage. So I'm just creating some new terminal to put everything there. So just source my virtual Python environment. Put a queryable. I start my storage. What if I do my put as I did before in Python? Hey, the put was received by the storage. It's matching. Good. Now it's stored. What if I can do a get? I can do a get. Hey, the queryable that was producing data for the bedroom just replied, but also the storage just replied for the kitchen. So I was able to get this sometimes from a query, either data that was stored, but also freshly produced data. With a single API, single mechanisms, boom, you're in business. And you can see that in this case, we got two replies because one was for the room, for the kitchen, and one for the bedroom. So Zenoh consolidates things only for the same exactly key expression, but we got separate disjoint key expression, you receive data for all replies with different key expressions. So let's introduce another important concept in Zenoh, another important piece and component that we've got in Zenoh, the Zenoh router. what is a router and what is the routed communication model. Okay, routed is a communication model where one or more routers, so Zenoh routers, support the communication between peers and clients. What does it mean? It means that we might have an arbitrary complex infrastructure of Zenoh that can really distribute your data. So you are not forced to go through a full peer-to-peer mesh in order to communicate, but you might have a mix of those, either with peers or client. So how can you install a Zenoh router? We've got multiple ways to do it, right? We provide a Docker image, so either the latest for the latest published version, so 060 beta 1, or you can have the with the master tag that is the nightly. You can also download it simply from the Eclipse Foundation repository. So just remind you that Zenoh is an official Eclipse project. So we also have our binary artifacts stored on Eclipse, and you can also use that same space on Eclipse. We also provide some way to add as a repository for a Debian package. So you can add your mirror for Debian package, and you can install it also for that. Or if you really want to go for that, you can also have the nightly versions built by yourself on GitHub, right? You clone your GitHub repository and you build it. So what will happen if you've got a router in the middle and we've got a set of peers or set of clients? So if we add a router in the middle and we've got some peer, how will they combine them? So if I got, for example, communication from one peer to one peer in a peer-to-peer mode, that kind of communication will always stay local, right? It will not go through the router. But if, for example, let's assume that we've got this router connected to another router, then all remote communication will only go through the router, right? So local communication stays peer-to-peer. When we're getting peer-to-peer, only remote communication will go through the Zenoh router. But if you are in a client mode, so that means that a client needs to connect to something, that something is a router, all communication will always go through the router, right? And we can have it all combination, right? I'm going to show it later. How can I pass then the next question? I've got my application that is running in a peer-to-peer mode, and now I want to move to routed. Well, you don't need to change anything in your application logic or to use a different API. You just need to set the right mode on your application to either peer or client. And here are just an examples how you can do it in Python, Rust, or via configuration file, right? This you can see that in Python we support the JSON5 support. In Rust we've got some accessors. But what you can do, you can also dump all your JSON5 to a configuration file and to read it on a startup time. And that's enough to do. You don't need to change anything in your application logic, right? We're going to just have a look to an example, right? For a subscriber in Python, that is, just put always on the right, the subscriber, so it's easier to identify. Everything that you need to do is I've got a subscriber. We've got a configuration that is not the default, but just created from a JSON5, where I explicitly set up the mode client. This from JSON5, I could have read a file, a JSON file, and just put it in it. Will work the same. So that means that you don't need to change anything in your application if you upload that to a file. And what would be the impact for that? Let's get back to our Python code, just example. So creating some new terminals for that. Just I've got on the right, top right, a subscriber, and just running a publisher. That here is a peer-to-peer. That's fine. Here I can start a subscriber in client mode, just to choose a different environment. Nothing will happen to the subscriber because we don't have a router. Say, hey, I failed to find any router in the middle. I cannot open my session because nothing's there, right? So that means that now I can start a router here that is listening on call port 7447, and I can start my subscriber with a client. Hey, now it's receiving data from the publisher. This publisher was a peer, right? So what happened here, right? So we got a publisher that is in a peer mode, a subscriber that's a peer mode, got Zenoh router, and a subscriber that is in client mode. The publisher discovered the router, also open a connection. The subscriber discovered the router, also open a connection. And now I've got that communication. There is direct communication between the subscriber in the peer mode and the publisher in peer mode. And the client is connected to the router. The publisher is also connected to the router. And that communication will go through the router. You can see that what happens if I kill the router now. You can see that in the peer mode, even the router went down, we can still receive data. But our client, no. They just restart the router, we'll just some point they rediscover each other, and boom, we keep receiving data. So can always also think that in this way, when having a router that will allow to do that, right? If I've got a router, we got peer-to-peer communication that really show that local communication stays locals and remote communication or some hop away will go through the router. So let's see a next step, right? So let me just, I forgot to do it beforehand, but let's start a Zenoh router on the cloud. And just connecting to the cloud. Okay, it's here. Straight here. So here on the cloud. And what I'm going to do, I'm starting also a router here. So this router is hosted on demo.zenoh.io. So what I can do for that now? I can tell, just stopping here to not introduce additional noise, actual router connect also to remote router. Do that by passing the parameters -e, and that is the endpoint that we want to connect to. And here we go. So now these two routers, the one on the cloud and the one locally, are connected. So what can we do for that? What does that enables us to do? So at this moment, basically what I did is I bridged my local machine with a router in the cloud, and that would allow to do very nice things. Let's restart again, for example, our storage, our queryable, and I just do a put for that. What if now and all of you can do it right now. You can open your browser, go to demo.zenoh.io with the port 8000, and you can do a get with that. And it's like an HTTP get that is translated by the Zenoh router to Zenoh. You can see here we got a queryable and a storage that could answer questions, queries via our router. So all of a sudden, because we introduced a router, we were able to connect that router from my local machine to a router remotely everything that happened is that I breach all the communication all the way down, right? So, but how we were able to do that, right? Really, this to tease you for what's coming next, also for the next episode, for what comes for plugins and different type of storage. So, as I said, beginning really the introduction that with Zenoh, we are extensible, so we can integrate with additional technology. So one of the plugins that comes out of the box with Zenoh and the Zenoh router is the REST plugin that really maps Zenoh to HTTP methods and HTTP methods to Zenoh API primitives. You can see that by doing a get on HTTP on your browsers, you can tap into the Zenoh router that will route from the cloud down to my machine, local machine here with me, and all the querybles in the storage will be able to reply to the query. In addition to that, we also have a plugin for web servers. You really want to serve web content, but also to plug into bridge with other communication messaging protocol like DDS and QPT. Plus, as we've seen today, right? It was really for tutorial point of view, we create a storage, but out of the box, Zenoh comes with a storage plugin, right? That helps in creating and integrating with the different storage technologies. This built-in Zenoh router supports multiple backends. That multiple backends like in memory, similar to what we showed today, or if you want to store data on file system, or for example, in InfluxDB, if you want to have a persistent database for time series, so you want to do some data analytics or some machine learning on it, you need a time series, you can get InfluxDB backend. Or for example, RocksDB, you want to just have a persistent key value stores. Or recently added Amazon S3 backend. So just get a router backend and you connect to Amazon S3. And many more are to come. Right, so also room for contribution there if you fancy to contribute a backend. But more details how to build really the plugins backends will be dedicated to our next episode. So this just a flashlight on what you can do with Zenoh, what is around. But I would like to just summarize really what we've seen today is how to get started with Zenoh, right? The basic principles, basic APIs with Pythons and with Python and Rust. So how to build a PubSub and a query reply. How can PubSub and query reply can be combined together and magically it becomes a distributed storage for it. And then how you can pass from a peer to peer mode to a client mode with a router. So you can see that also for failover in a peer-to-peer communication to remote communication, you can just go through a router, but if the router for any reason could go down, local communication stay alive, and remote communication can be enabled, for example, for local machines to the cloud to really get all the queries, publications, subscription routed from any different location on your systems. Having said that, so I think we're good in time for leave sometimes for the question as well. But just don't forget to visit our Zenoh websites where you could find some more documentation, use cases, and some links also to community channels, YouTube, GitHub. So please visit GitHub if you like Zenoh. Please put a star on Zenoh repositories. So we just passed 600 stars a few days ago, but we are aiming at least for 1,000 stars. So please help with us for that. And any questions? We've got a Discord server for that. It's open. You just need to register. The link is here on the slides, but you also find it on the website. So I hope to give you a bit of hype about to get started with Zenoh. So please, if you have any questions, I'm really happy to take them. So how can I use protobuf in Zenoh? So protobuf, in the same way that there are two ways of saying, like one short term that since protobuf is not supported yet by out of the box by Zenoh, you just take your data, you serialize it with Zenoh, and you can use your custom encoding to say, hey, this is protobuf. And something that could be more long-term, since we already have, for example, JSON, we might have, for example, support for protobuf. Of course, then you need to have your protobuf definitions, but you just take your data, you serialize with protobuf, you pass it as a series bytes to Zenoh, and if you want to identify what's that, you can use the custom encoding field to signal the receiving side what's inside, right? How to decode it. So to the next question, well, next remark is it would be great to have a Redis integration. Yes, it would be great that backends have been open, so we are adding little by little multiple backends. One of the latest requests was to add Amazon S3. That's what was on our roadmap. Having Redis, of course, is of interest. We can add on the roadmap itself. So just since I'm talking about roadmap for everyone, just to make aware that everything is. Oh, I can. I'm just showing here. I couldn't move. Eclipse.zenoh/roadmap. If you want to propose new features or something that you would like to engage with, there is all a discussion. So if you want to propose new features or something that you like to see, to engage for something that you like to see in Zenoh, really, in addition to the Discord channel, we also have the discussion forums on GitHub. So, for example, this kind of points on, hey, can we get Redis? That's an amazing place where to put it, for example, either in the chat today, in the tutorial, but also in the discussion. So feel free to get it also there. Next questions. So using a sync task for each queryable, we can have the Zenoh node wait for queries on multiple key expression, reply to them. I'm not familiar with a sync in Rust. So you can have for different querybles, you might have a dedicated task. So a queryable answers to a given key expressions. So just bringing up again the example right in the storage, just to make it easier to follow. Okay. So in this case, we've got this queryable that will reply to this to this key expression. You might have a different key expression that will work on parallel, saying that I don't want the temperature, I just want the humidity. I can do the same things. So things could be served in parallel, depending on the key expression you want to have, right? So you get there, you get your own task that can work on that, and you can get multiple queries separate and very well, let's say, limited in scope for what concerns your code. So if you've got multiple querybles, asynchronous tasks are cheap, are not multi-thread, right? So you can really easily go for multiple tasks, and it will help you to keep your code in a single place and have all the logic in a single place. According to you, what makes for good database choice for the storage? What should be considered? So for storages, really depends on your use case. So on your use case, the first question will be, why do I need to store some data, right? So that means that that data has meaning to you for your use case, your application. And that meaning could be that, hey, this data just some logging that I want to store it for a long time. And for example, you might have to log events. So in that case, for example, InfluxDB would be a good choice, right? So you always log an event. You want to keep the full history for that. You want to have some fast caching really close where you are, and you don't want to go for the to write on file system. Go for in-memory. That's really a good use case for fast caching. Really, you put a storage close where you need it, and you read and write very fast from it. File systems, for example, you want to sell files, right? Let's assume that I've got, I want to sell some pictures or these kind of things. You might have those pictures on a file system. You just plug in file system backend, and you can start serving pictures from it, right? So the real question is, you've got different databases for different purposes, right? The same way that you've got InfluxDB that is different from SQLDB, that is different from Redis, and the same reasoning for which you will pick, right? InfluxDB, Redis, MySQL, file systems, memory will also apply to Zenoh. So what do I need to store and what for? And then you just plug it in. So I see that okay, just a remark for what again, the storage, to follow up on that. So everything that you can use to read and write, you can use it really for database backend, right? So at the moment we provide out of the box CS backend that I showed before, but as soon as you're able to really subscribe to a queryable and to read and write on something, you can use it as a backend, right? Then got a question. So what does @/something key expressions means? The usual for Zenoh users. So I didn't went into the details for that, just for the sakes. But if I go again here, I did my query on room /star, but if you do on ***, hey, what's this? So this is everything that starts with @ is related to what we call admin space, right? So we're gonna have a next episode more in details on that, but allows you to get more information, administrative information on the state, on the configuration of your router and the actual state, right? So for example, here I can see the path for my plugins, for example, for the REST plugin, where it is stored, where it was loaded, or for example, the active connection that I have, right? So, or where I'm reachable at, right? So that kind of information is really administrative type of information that you can either use to read or to pilot, for example, some certain actions. Is useful for the users? Yes and no, depends what the user means, right? If you're a simple application that like you're writing some data like my temperature, most probably you wouldn't need to get access to that information. But if I, for example, building some super monitoring application that gets the state out of the routers, or to monitor, needs to detect to which endpoints is actually connected to, or what kind of events will be supported to, yes, if you want to react to that, you might have interest in looking into it. Something that is coming in the next release, it will come in next 3 weeks, more or less. We are adding some event support to be notified on the admin space to whether you receive new connections. For example, let's assume that I'm a peer. How can I detect that some other peers connect to me? That kind of information is what we are going to expose for the next release by the admin space, that it will be under @/something. Just a remark. So the API of Zenoh, so the publisher, subscriber, etc., is it was really a huge effort from the last release. You consider to be stable. Admin space, you can look into it, but still is a kind of experimental state, right? So we are still doing some work on it for what concerns the structural information model that. So you can use it, but it's still considered an unstable feature. So get another question. So for what concerns going back, so another remark on that. So, for example, for ProtoBuff and certain things, that is something that we could do also to provide some example in our blog. So we've got a blog in our website, if you're not aware of it. So something that we could do is to show how to use this ProtoBuff via a blog post to give you some information, example on how to use it. There is another questions. Will this new connection data be used to implement lifecycle hooks, for instance, to make sure dependent nodes are alive and healthy? It could be. That's one way that you could use it for. That's one way, but not the only way, right? Exactly. So it's just a comment from Angelo on the Zenoh's group management for this. So this are available in ZenoX. So one way is to get that kind of notification, but also another way is to use a group management library that is available in ZenoX to make sure that when you build a group, you have got persistent states to discover who is there and when you're good to go. And I think we already 6 minutes past the hour. Got to receive a good amount of questions, so a good amount of a pleasant number of attendees, I will say. And thank you very much again for attending. So if you really like this getting started, well, at 6 p.m. we have got another one. If you really want to attend twice, otherwise we'll make available also the recording. Okay. Thank you very much, everybody, and have a nice rest of the day. Bye.